I was given this sign from a scrapped aircraft and asked to see if I could rebuild it and illuminate it so it could be used at home. In this video, I'm going to look back over the process, finding out what was inside, what needed to be replaced or repaired, how it was going to be powered, and what the general steps were to make it suitable for use at home. So first of all, let's go back and take a look at the original sign. The board has an outer panel with a diffuser for the logo. Looking inside, we can see the diffusers for the edge LEDs and a central frame with electronics on, PCB boards attached to it. And this clips out, let's clip it out, and switches off the power when removed, which is a really good idea. There are several circuit boards around the edge. In fact, there are 9. I've removed one to look at it. And you can see that each one has loads of 5mm LEDs on it. And each of these little boards also has its own circuitry, chips, transistors, etc., resistors, regulating power, dimming, safety, data transfer, and so on. The central logo board has a pattern of LEDs in the shape of the logo, and again lots of electronics, chips, connectors for the little boards, power regulation board, and a data input socket, because presumably the captain or the crew or whoever could dim and control the lighting. Obviously power regulation and safety is very important. The power in an aircraft is quite high, which is useful for this because it will need lots of power. So the mains voltage is like 110 or 220 or more. There'll be lots of power running around an aircraft from the generators in different voltage levels. And with all these LEDs, lots of power is needed and lots of power is available, so it's not an issue for the design like it would be at home. But looking at this and having done some experiments, I can see that I cannot just plug into these boards and light up these LEDs. And to do this at home, it's become clear to me that all these boards are going to have to come out and be replaced. So the next step to make it work as a standalone unit is to figure out a plan as to how to make replacement boards with a suitable number of LEDs on so that they can just fit in and work with the minimum amount of power. Having made the decision to take the panels out, I obviously now need to figure out how to put them back in. The diffusers are already in place, so I've decided to make some replacement panels for the circuit boards using fewer, larger LEDs than before. I'm going to 3D print some panels of a similar size with matching screw holes and obviously holes for the new LEDs. I'm going to use 10mm clear white LEDs, that's 3 for each of these little panels, making 9 per side, which I hope will give enough light to go through the diffuser. And for the central logo, again, I'll make a pattern of LEDs but with fewer of them to give just enough light to illuminate the diffuser and the logo. So the next step is to measure up, make some notes, measure these screw holes, measure the size of the boards, and make some notes, and then draw some outline panels using 3D CAD software. I'll do that and then I'll come back and have a look at how it all fits together. I've made a prototype edge panel just to make sure it will fit. The LEDs just push into a recess. It fits perfectly, so now I can go ahead and make all 9 panels. This test is just from some blue filament left in the printer, but I'll make the final panels bright white to reflect all the light from fewer LEDs back through the diffuser. I've designed a logo board with a pattern of LEDs and a couple of fixing screws to match. And my time-saving project for making anything like this, which is 3D printed, is to produce a cut-down version first to make sure it all fits. So what I've done is cut out most of the block, most of the board, and I've just printed it a couple of layers thick so that I can test it and see it fits, and then I can print the whole panel later, which will take 3 or 4 hours. This just took a couple of minutes, so I'm going to hold it now on this board. I don't know if I can see that properly, and it matches all the screw holes. So now I know everything will fit, I can go ahead and do a full print of all the boards. And once I've done that, I'll come back and have a look and review everything else I'll need for completing the project. Here are the printed panels for the LEDs. Got the centre one for the logo and nine different panels for the edge logos, the edge LEDs rather I should say. So I'm just going to finish removing these existing panels, whoops, there's a transformer, and check that they fit. So here's one of the edge panels as well, now fitted. Check that it lines up with the holes, which it does, and that has room for 3 LEDs which will shine through this diffuser here to the edge. So I can tell those panels line up, this one lines up, so everything's fine, and I need to obviously take them off now and wire them up. I also need to think about how to power and connect all the LEDs together. Each panel will have 2 power leads coming from it, so I'll bring all those together in a terminal block on the central board, and there are already holes there to attach that. I'll also need a socket to plug the power into from an external power pack, some voltage regulation and a switch. I'm thinking about doing either 1 or 2 circuits with a voltage regulator, maybe one for the edge, one for the centre to spread the current load, but it may not be necessary. Anyway, I'll finalise the details of all that once I put all the components in place. So now let's wire up the LED boards. The edge panels have 3 LEDs each and the logo panel has 13 LEDs. The LEDs fit perfectly into the recesses and there is a ridge to hold them all in place at the same depth. The ground leads were all bent over and soldered together. Each positive lead needs its own resistor though, so I added those and joined the other end of them to a power lead running along the board. The voltage on the power lead will be 5 volts from a regulator. The LEDs need 3 volts at 20 milliamps. For each board with 3 LEDs, the total current requirement will be 60 milliamps at 5 volts, and the test on each one showed this was indeed as expected. The logo board has a similar arrangement with more LEDs this time. It also houses the terminal block to distribute the power. Now all these panels are complete. Let's take a look at how to set everything up to work safely together. I've finished fitting the wired up LED panels to the frame. There are the 9 edge boards with 3 LED each and the central logo board with 13 LEDs. I decided in the end to use just one circuit for all the power. The edge boards have 18 LEDs between them which will draw about 1/3 of an amp, and the central logo board has 13 LEDs and that will draw about 1/4 of an amp, so it's much less than 1 amp. So I've used an L7805 voltage regulator to give me 5 volts no matter what I put in the socket, and that can handle up to 1.5 amps, so it's running well within its capabilities and there's no chance of any excessive heat. If there is any heat, it'll be dissipated because I've bolted it to this metal chassis to act as a heatsink, so that should be fine. So I've wired power to come in through a socket, into a switch, into the regulator and to the board where everything is shared between these LEDs. So now let's plug it in and give it a try. Oh, and by the way, if you're interested in knowing how I worked out which resistors to use for all these LEDs, then do watch All About LEDs Part 1, where that's quickly and easily explained. And there are other episodes in that series, of which in a way this is a part, because this is a practical use of understanding how to use LEDs. So that's now plugged in and let's switch it on. Yep, and everything's lit up. Let's just look at that from the front. Here's the logo. Everything's lit up. So hopefully that's going to be brilliant. Let's now put it in its case and see what it looks like with the logo. Let's try and get it the right way around. Here we are. And that should just drop into the case. Click, click, and here it is, and turn it on. I'm really pleased with how this has turned out. I'm very happy to give it back to my friend as a working sign for his study. As ever, I hope you found this video interesting and enjoyable. I really loved rebuilding this sign and making it work again, and I'll be making more videos about lots more projects which I've got on my bench very soon. Thanks for watching.